partitioning clustering algorithm. So K-means is a partitioning clustering algorithm. We're gonna do the same thing as we mentioned earlier. We take points that are plot that we will take our data and each object plot it into space. We will have as many dimensions as the number of attributes that we have. In this case, we have 1, 2, 3 attributes. So we have x, y, and z dimensions, 3 dimensions, each corresponding to one of the attributes. So the first point, x1, value for first attribute is 0.8, and value for second attribute is 1.2, and value for third attribute is a. So x1 is right here, 0.8, 1.2, and a. x2, value for attribute 1 is 0.75, value for attribute 2 is 1.4, and for attribute 3 is b. So x2 is here, x3 is here. It has 0.23 for a for first attribute, and 0.4 for the second attribute, and x is here. So all the points, we will plot them in space like that. The idea is that we want to find groups of similar objects together. We are not telling the class of the attribute because we mentioned that clustering is unsupervised learning. So we are not telling the class here. They could be a class in the data. The class could be malignant or benign tumor for these objects because this is the curvature of the tumor, the texture, and the blood consumption of that tumor. So the class could be benign tumor or malignant tumor, but with unsupervised learning, we're not providing the class information because we are not doing classification. Remember, the classification is not clustering because with classification, it's supervised learning. We are training the algorithm and we provide it with a class. In this case, we don't. We're going to discover groups of similar objects together and later on try to find some description of that group. What makes them to be similar to each other. So let's follow the K-means algorithm. We recall from the previous lecture, the way the algorithm works is as follows. First, select K points as initial clusters. Next, repeat. Form K clusters by assigning all points to the closest centroid. Or we compute the centroid for each cluster. And we will keep doing this until the centroids don't change. time we repeat, we will have a new iteration. We have seen in our slides earlier there were 6 iterations until the point stop, until the centers stop changing. That's when we say that the algorithm has converged. Let's do an example. Cluster the following 8 points. Representing locations into 3 clusters. So we mentioned with k-means, k is the number of clusters, and that is always provided by the user. In this case, they told us we want to have 3 clusters. The points are A1, coordinates 210. Now, this is 2-dimensional space. We have 2 attributes only, x and y. So we have x coordinate and 1 coordinate in this problem. The x for point A1 is 2, the y is 10 for that point. Point A2, 2, 5. Point A3, 5, 8, 4. Point A4, 5, 8. Point A5, 7, 5. Point A6, 6, 4. Point A7, 1, 2. Point A8, 4, 9. The first thing the algorithm says, select k points, k is the number of clusters, as initial clusters. We mentioned we're going to choose this by random. In the problem we're told, just pick the 3 points as initial center clusters. Initial cluster centers are A1, 210, A4, 5, 8, and A7, 1, 2. Now, we mentioned we could use a Euclidean distance, which was the most intuitive distance, that is everyday distance. When you say from here to the middle of the classroom is 12 feet, that's Euclidean distance. That's what you think about when you hear distance, or that's the most intuitive. However, if we have binary numbers, or if we have ABCD or something else here, or depending on our data, we might choose a different distance measure, or we can even define our own function for what is distance, how this distance will be calculated. So in this problem, they're giving us the function of how to calculate the distance. So the distance function between points coordinate x1 and y1, and B with coordinates x2 and y2 is defined as distance rho between A and B equal absolute value of x2 minus x1 plus absolute value of y2 minus y1. This is also called the Manhattan distance or city walk distance. So use K-means algorithm to find the three cluster centers after the second iteration. Now, this problem is, they're being very nice to us in this problem because they say, just give me the centers after the second iteration, because normally for this algorithm you have to keep repeating or having as many iterations as necessary until the centers don't change. In this case, they just told us just do the first two and that's it. So that's much easier for us. So let's see how are we going to do that.